I'm Nick.
And I'm Cooper.
And for our physics video project number 2, we did question number 4, which reads, the figure shows a 6 kilogram sliding cart on a horizontal track connected by a string of negligible mass over a pulley with a mass of 4.0 kilograms, a radius of 2 centimeters, and is modeled as a solid disc. And the pulley is connected to a hanging mass. The coefficients of friction between the cart and the track are mu k is equal to 0.20 and mu s is equal to 0.45. The hanging mass falls by 25 centimeters. For our coordinate system, we decided to have y, the positive direction in the y to be up, and the positive direction to be in the x to be to the right. And for our origin for our y direction, we established it to be the height of the track itself, the initial height, and the origin in the x direction to be the initial position of the sliding cart.
Part A asks, assuming the pulley does not spin, determine the speed of the cart and mass. First, to solve this, we calculated the gravitational potential energy. This negative 19.6 joules is also the total amount of energy in the system, which is then converted into kinetic energy to the cart, the hanging mass, but you also must account for the energy lost to the friction due to the cart on the track. We solved for V and obtained 1.54 meters per second.
Part B reads, assuming the pulley does not spin such that the string passes over it without slipping, determine the speed of the cart and the mass. Here you may assume that the pulley spins about its axis with negligible friction. So in the last problem, the string did pass over the pulley with slipping. However, in this problem, it is different because now you have to take into account the rotational kinetic energy that is lost, that is distributed into the pulley system itself. Therefore, we again set the total energy equal to the original 19.6 joules that was calculated to be the gravitational potential energy, which is then distributed into the kinetic energy of the cart, the hanging mass, and now the rotational kinetic energy that is lost in the pulley, and then again taking into account the frictional force of the sliding cart on the track itself. Solving for V, we obtained that the velocity of the two carts is equal to 1.44 meters per second.
Part C asks, if the cart and mass have a velocity of 1.2 meters per second, how much energy was lost to the friction by the spinning pulley? This is very similar to Part B, but now there is friction in the pulley system. We use the same formula we used here, 19.6 equals all these energies, but now we included the force of the friction done by the pulley. And we used 1.2 meters per second instead of 1.44. Solving for the force of the friction done by the pulley, we obtain that this is 5.14 joules.